first things first, we would like to thank you all for the interest and exchange in the webinar series so far. It was a great pleasure for me and Stefan to give you an idea on the company and our vision for future mobility solutions. And even though this is the last date of our scheduled webinar series, we will be back after the summer break. We are still planning the dates and the exact contact, but in a nutshell, we will cover the topics alongside our R&D application areas, especially for our other application areas like hardware replacement and predictive maintenance, especially with regard to the software-defined vehicle. So stay tuned, and we look forward to see you here. And another off topic today, which we are very proud of, I have to say, some of you probably already saw it yesterday, that there was quite something going on our LinkedIn page and in the web with regards to company. And this is for a very special reason, as we are proudly able to announce that we have successfully closed our Series B financing round way ahead of schedule. This is a very cool process for us, and we are very happy to have two strong partners in this financing round, especially first, already known and firmly anchored into our portfolio of existing investors, which is Shift for Good, the impact fund for sustainable mobility, which already came on board on Series B. And secondly, our new investor, which is Woven Capital, the growth fund and investment arm of the Toyota Motor Corporation. And this funding round will enable us to expand globally, extend our existing range of virtual sensors, and take the company and the team to the next level. We thank you for your trust and look forward to work with you in the future. And now back to Stefan.
Yeah, thank you, Daniel, for sharing this great news with our audience, as this is really a major milestone for us, and we all can't wait to entering the next phase of growth together with our partners, customers, and of course, old and new investors. But now, I would say let's start with our today's webinar content and our first agenda point: why using COMPREDICT's virtual sensor platform. As competition intensifies, development cycles shorten, and I would say new technologies emerge at an even faster pace, the make or buy decision was never as important for OEMs as today. And the same challenge we also experience with the AI adoption time in the automotive industry. So we have a massive talent shortage in AI worldwide, which of course makes it really difficult and time consuming for OEMs to hire these talents. And even if the OEMs make it to get this right talents on board, the testing and tuning of AI models to really have like scalable solutions in place is also very time consuming and of course prone to errors. And this is today resulting in a huge problem for OEMs, as the average adoption time of new technologies of 5 to 7 years is way too long to keep up with the high demands of the markets and of course with the demanding customers.
All right. Again, coming back to the virtual sensor role in this deep-picked situation of Stefan. First, in the first webinar, we've been talking about the virtual sensors in general. In the second webinar, we've given you an explicit use case. And this time we want to focus more on the process bringing virtual sensors to actual life. Basically, everything starts with the data acquisition. So we always say our work starts when vehicle data is available. And this data can come from several sources. So we can talk from early prototype vehicles or even from series production vehicles. In the past, we have also been working with test bench data. But as you saw in the second webinar, a dedicated measurement campaign is the way to go, in our opinion, in order to be able to have the right data in the right place and provide the best data for the accuracy of virtual sensors. The calibration process, so basically the entire main process, starts with a far-reaching data check, where we check the data if everything is good to go. remove outliers, and so on. And then basically our IP and core magic happens within the feature engineering section. So what we are doing here is selecting the right data for the right use cases and the right spectrum of data in order to feed the virtual sensor with the right information. And after the actual virtual sensor calibration, the virtual sensor has to live somewhere. And there are basically two opportunities here. First, in the cloud. We will come to this point in a minute. Especially relevant for R&D cases, but again, we will come to that. And secondly, obviously, regarding, for example, the implementation stack of our investor BlackBerry, we drive to implement virtual sensors directly in vehicles. Obviously, the right implementation strategy varies from use case to use case, but the core message here is that we are capable of doing both directions, I would say. In the past, the process or this virtual sensor calibration process was mainly carried out manually by us and the team. And this changed significantly at the beginning of this year with the launch of our new product, the Virtual Sensor Platform. With this software tool, we provide our customers with our expertise in calibrating virtual sensors and enable them to carry out their own projects adapted to their own data and vehicle structure. And this enables our customers to have their own virtual sensors ready to go with just a few clicks and just a few days. Our portfolio within the virtual sensor platform started with one of our favorite applications, which is the reforce transducer. So now you get an idea on the actual process of this webinar series and why we are here. But we are about to release a significant update, including 3 new use cases that we've been working on for quite a while now. Which is basically dealing with the virtualization of strain gauges. So in this case, we are going to add 3 new functionalities to the platform, which is the replication of tie rod forces, damper forces, and drive shaft torque. 3 very interesting use cases, especially when you think of electric vehicles. And now I think we can come to the core of this webinar, giving you an actual idea and live presentation of the platform. Stefan, stage is yours again.
Yeah, thank you very much. I have to stop the sharing and share a new window. And here we go. What you can hopefully already see now is the landing page of our virtual sensor platform. So this means when you're getting access, when you're getting your login, you directly have all virtual sensor projects in place, which means all the virtual sensor projects, it doesn't matter if it's just a draft, if it's calibrated or it's already deployed, you all have it on one page, you can sort and filter it. Also, you have directly the state of the data quality for this calibration, and you, of course, also have the option to edit and delete projects. What I want to do today is really guide you through the process how to calibrate a virtual sensor by yourself, even without any prior ML knowledge. And therefore, we will just easily start a new project. We will name the project. Maybe we go for webinar 3. And then we select the virtual sensor. In this case, of course, like a wheel force transducer, but as Daniel also said, there will be even more virtual sensors in the future. What you also can do is select the powertrain type, which means you can go for combustion engine, a single electric motor or dual electric motor, for example. In this case, we are just going for a combustion engine and we are creating the project. Next, in our user interface, you as a user have to select the target for your virtual sensors. What does this mean? You're selecting the targets you want to virtualize with your virtual sensor that you are calibrating. Of course, therefore, it's really important that you have for the reference vehicle, which is the target for the calibration and is equipped with the actual hardware sensor, that you have all the CAN data and also the hardware sensor target data in place for the targets you want to reproduce. Of course, you can go for all the targets, like all forces and all torques. In this case, we would go, for example, on rear left for longitudinal, lateral, and vertical forces. and continue. So these are really the targets we want to virtualize in our calibration. We confirm the targets, and then we are getting directly to the next step. There, we have to select the reference vehicle. Keep in mind, the reference vehicle is really the vehicle that was equipped with the actual hardware sensor. And therefore, you need CAN data and the hardware sensor target data. You can easily create a new vehicle if you didn't create it now. If you already have the reference vehicle in place, you can go for just this vehicle. And what is really important in this step, if you are creating the vehicle for the first time, of course, you're saying like, okay, how do they know which data do they need? There we have an automated signal mapping in place where you upload a sample data file, and then we connect your signals with the signals we need so that we ensure that we have all data in place to have a really good calibration. In this case, we are going for the reference vehicle. We already prepared with some data. Click continue, and then we have to upload all calibration data. So this is really all the CAN data and all the target data you have in place from your measurement campaign. Normally, this is 1 to 3 hours, as you see here. And of course, for this demonstration, we already prepared this data. So in this case, we skip the upload. And now you're already getting to the last step before the calibration. So what you can see on this calibration confirmation page is like the vehicle you selected, which is the reference vehicle, the virtual sensor you want to calibrate for, the wheel force transducer, and the targets that you are selected. If you say, yes, I'm good to go for this one, you can click confirm calibration. In this case, we are clicking save and leave because, as Daniel said, calibration takes a little bit. To give you also a definition of what does it mean takes a little bit, normally you are good to go within 1 day. On average, average calibration time, what we have is like 8 to 9 hours. But we say within 1 day, you're good to go and you have your virtual sensor in place. In this case, we say save and leave. And now you can see we have the Webinar 3 project as a draft on our landing page. And of course, you will get notified once the calibration, which is completely automated, will be finished. And then it has the status calibrated. So therefore, we are going into this project. And you directly get to the calibration results page. This page, of course, directly should show you how is the accuracy of the virtual sensor you calibrated by your own. So you see, again, the selected vehicle, reference vehicle, wheel force transducer. In this case, we selected all the targets, and you also see data quality good. Within the calibration, we are also doing an automated data quality check, which means that we directly give you feedback if it's a good quality, if you have warning in the data, or if the calibration failed and why. In this case, of course, data quality is good and you're good to go with your calibration. What you can do now is that you have for all the targets, the RMSE and the duty value, and you can directly check how good the virtual sensors you calibrated by yourself performs. But this is only a first overview, I would say. What you also, of course, can do is that you can go for a deeper analysis. And there you are going into the visualization where you see like we selected now the reference vehicle, and then you can directly go for all the data you are uploaded. So you see like all the forces, the reference and the predictions. In this case, for example, we can go for the longitudinal wheel force front left, the reference signal. And then, of course, we can also go for the longitudinal wheel force front left, the prediction. This means in this step, we have directly the data and the trips you uploaded for the calibration, and now you can zoom in. So which means that you can directly zoom in and see how good does the virtual sensor performs. And in blue, you see the reference vehicle, the target, and in green, you see the prediction from your model you calibrated by yourself. And therefore, you can go for different trips and different timestamps also in your data and see if also the peaks are well virtualized by your virtual sensor. In this case, you also can go for the deployment, and there we can deploy the virtual sensor. Of course, you're back here, and now you're saying, okay, I've visualized everything. Now I want to deploy it. And of course, this is like the most important step for you. So within the deployment, you also go back to the vehicles, and there you have all the vehicles you can deploy the virtual sensor you calibrated on, which means it really not depends where these vehicles are, because we are doing it over cloud, could be Norway, Japan, or US. And it also doesn't depend if you already have data in place from the past, or if you are going for measure more data in the future, because you can connect the vehicle, and once the data, the CAN data in place, you are also getting results from the virtual sensor. In this case, we confirm the deployment, and you can directly see, now we are at the deployment review. You still have the chance to review the calibration summary, so the accuracy of your virtual sensor calibration, and you can go for the deployed vehicles, which means that now, for example, for the Japan vehicle, where we also uploaded data up front, you can visualize the results. And there you can see, again, we can go, for example, now you have all the CAN data and also all the predictions. So wheel speed, rear left, for example, and we also go for lateral wheel force front left, and you directly see all the data points that are uploaded, so all the trips. And now you can, of course, zoom in again and directly can compare the signals to each other. And the good thing is that you also see when data are missing. So when your measurement campaign, for example, misses data, or your data logger, there's also direct information on this one. And you have the chance with two y-axes, so resolution per minute, for example, for the wheel speed rear left, and you have on the right hand the newtons. What you also can do is like save as an image the plot you had, or you can also generate the CSV. And of course, you also can go for your time zone. So now you have really all the data in place, all the outputs of our virtual sensor. And yeah, I would say that's it. Then you can, of course, always go back to the landing page, manage all your projects. And yeah, let's continue with the further content of the webinar. I will share again, of course.
All right. Yeah, thank you, Stefan, for the live demo. Fortunately, everything worked, which is always a good thing, especially in a live presentation. But we were quite convinced that everything is good to go. And I think we gave you a quite good idea on why we did develop the platform, what's the reason to use it. However, we would like to give you a rather example of an actual customer that we had in the last couple of months. So what was the customer situation? So we're talking about OEM here, and we supported them utilizing BSP as part of their R&D process. So the situation was as follows. They had several vehicles sent out to different global locations as endurance or durability testers for the validation of different situations within their R&D process, like road situations, environmental situations, such as hot environmental testing, cold environmental testing, and so on. And anyone who remembers the last webinar will know that for various reasons, these vehicles could not be equipped with additional measurement hardware and only collected CAN data. However, what was of interest of the customer was the question, how are these vehicles driven? Or in other words, which kind of stress these vehicles witness during the driving cycles? And this is basically where the virtual sensor platform came in. Because even while the vehicles were already driving various kilometers, we conducted a dedicated measurement campaign with a reference vehicle, which was equipped with V-force transducers, obviously. And this reference vehicle was similar to the other vehicles running around driving kilometers of kilometers. We collected then both data streams of this reference vehicle, as we presented you in the last webinar. So from the vehicle CAN bus data and the measurement equipment, which was the wheel force transducer serving as the ground truth data, and uploaded both data streams to the platform. But meanwhile, the customer also uploaded the data of the durability test fleet on the platform, which we were then able to deploy the virtual sensors to, even without touching these vehicles for one time physically, which was also, quite obviously giving a huge success with regards to their R&D process. And this brought various of benefits using the platform. First, as you could see, we were able to naturally expand the development vehicle fleet, utilizing the enriched data and information that was already available and accessible. Second, we were able to retrospectively evaluate vehicle data and turn it into WFT insights, as the development vehicles were already collecting data, obviously. And this gives a huge advantage for the customer utilizing the platform, as data that has been collected does not lose any value, even though there has no measurement campaign been conducted so far. But still, the value can be maintained, and critical time schedules within the R&D scenarios can be met more likely. And in summary, for this customer, which is a very cool KPI in our opinion, we were able to multiply the WFT insights by a factor of 200 in only 3 months of driving time. As I said, a huge advantage to fast and efficiently ensure that the R&D processes of the OEM are met, are not only sustainable, but also secure. That's basically, I think, a very good number. And that said, basically, I think we are already on the end of the third webinar series. So thank you so much for watching.